The third and final type of storage that's supported with ESX is NAS or NFS storage. And this is really cool storage because it allows you to take advantage of disk space that might be available on certain Windows servers that you have, for example, that you're not using. You can use that towards NFS storage, and we're going to talk about how you can do that. But NFS and NAS storage in particular is also relatively cheap, so you can get that for cheaper than you could iSCSI or Fiber Channel, and this is where a lot of the main advantages come into place. However, that being said, obviously you're going to suffer as far as performance. It's not going to perform as well as iSCSI or Fiber Channel, and you're also going to lose in terms of some functionality or technology. So this next slide here, I want to talk about some of the differences, what you get with NAS and NFS, and what you're lacking with NAS and NFS. So you can do vMotion, you can do DRS or Distributed Resource Scheduler, you can do HA or High Availability, and you can do VMware Consolidated Backup or VCB. Now what you're lacking, if you compare that to iSCSI for example, you're lacking VMFS. So you won't be able to do VMFS file system on a NAS storage. Now why is that? Now keep in mind, when we talked about NAS storage, we're talking about a storage device that is being presented from a host. So it's a file level storage, it's not a block level storage. We're going to talk about that in a second in the next slide. But another thing that's also missing, if you take a look at Fiber Channel, you won't be able to do any kind of Microsoft clustering services as well. And the final thing that you won't be able to do is RDM or raw disk mapping. So you won't be able to present a raw LUN that's presented from NAS to a virtual machine so that it can treat it as local disk. Whereas with iSCSI and Fiber Channel, the same way you would treat a physical machine and present it with a LUN from the SAN, you can do the same thing and present a LUN to the virtual machine and can take advantage of it. So NFS is a file level transfer of data over standard IP networks, so which means you can take advantage of existing infrastructure, put up a NAS device. That NAS device is going to present a block of storage. This block of storage will be treated as file level instead of block level because the host that's presenting it is the one that's managing it, and whoever you're presenting it to won't be able to manage it. They'll only be able to take advantage of it as available space. Now NFS is to Linux what SMB or server message block is to Microsoft Windows environments. The same way you can have shares on Windows, you can have the same thing with NFS. So NFS is to Linux was what SMB is to Windows, for example. Now by default, ESX servers allow 8 NFS data stores. However, the maximum allowed data store, NFS data stores, are 32. Now once we log into the VI client, I'll show you where you can go to modify this value if you wanted more than 8 NFS data stores available. It's really cool, it's really easy. Now as far as the NFS components are concerned, if we start at the top, we have ESX 3.5, which is the host that has a standard NIC adapter. The standard NIC adapter in turn connects via standard Ethernet cable, Cat5, Cat6, to an Ethernet switch again via Cat5 or Cat6 to the NFS device. This NFS device is what's holding the storage and what's presenting the storage on the network, making it available for ESX 3.5 to connect to this storage. Now as far as NFS connectivity goes, within ESX 3.5, the same way we configured iSCSI, so we won't be going through the same exercise. The same way we configured iSCSI, whereby we created a virtual switch and added the VM kernel port group, and then we also added the service console for connectivity. The same way you can use the same virtual switch to gain access to NAS. As a matter of fact, all we have to do now that we have iSCSI configured and we have a NAS device obviously on the network somewhere, we can go in and configure connectivity or access for this ESX 3.5 host to the NAS storage, and we're going to do that in a second. Now as far as failover and failback is concerned, the same rules that apply to iSCSI apply to NAS and NFS, whereby you could take advantage of NIC teaming or multiple switches. The same rules that we discussed for iSCSI apply here as well. Now let's talk a little bit about NFS and Linux. Now the Linux operating system is the native home obviously to shared directories accessible via NFS. NFS directories are defined and configured through the etc exports directory on the Linux-based NFS server, and the etc exports must define the trusted hosts, the directory name, and the parameters. All right, so now let's move on to some really cool stuff. How do we take advantage of a Windows server that has a lot of disk space that we don't know what to do with? We don't know how to allocate this space. We're not using it for anything, and we want to use this for NFS, or we want to turn this into NFS. So in any typical environment today, because disk is so cheap and because most of the environments now have SANs or some sort of SAN, you end up with local disk on Windows Server that's not being utilized. I think that the minimum disk that you could buy today for servers is 72 gig, if not more. It's probably 160 gig is the minimum that you could probably buy each disk. And if you have a pair, if you're mirroring or if you're doing RAID 5, then that increases the disk space availability. But still, if you have 70 gig and only 20 gig is being used, that leaves you with 40, 50, 60 gig that you could take advantage of. So most of those servers have a lot of free disk space, and we're going to talk about how we can turn this disk space into an NFS storage that we can present to ESX. So the first thing you want to do on the Windows server that you want to turn some of its space into NFS is you want to go ahead and Google Windows services for Unix. You're going to come to a download. It's a package. You download it, you basically install it, and we're going to go through some of the steps. I didn't want to demo this here because I didn't want to, light up the focus on this particular issue, as this is kind of secondary to ESX. But for you guys that want to play around, this is a fantastic little thing, fantastic little project. Another project I would strongly recommend that you try is a free product that's called FreeNAS. FreeNAS is one word. Go ahead and Google that. You could download that. I tried that. I tried installing that inside of a VM on VMware Workstation on my local PC and created a NAS server out of it. It works fantastic. You could take that FreeNAS, and it's very, very small footprint, by the way. You can install it on any server that you're not using, or an old server that you can use just for storage. Turn that into an NFS, put it over the network. Whether you're using this for home or even in your organization, is just a fantastic little application. Again, try to Google it. It's called FreeNAS. Alright, so once we've downloaded and installed the file services for Unix, again, go ahead and do a search for Windows services for Unix. We're going to enable NFS sharing on the folder, and we're going to show you how we're going to do that in the next steps. We're going to copy and import the etc group and the etc password files from an existing ESX server, and I'm going to show you how you could do that. And we're going to use a VM tool called FastSCP to connect Windows, or even to do Windows to Linux or Windows to ESX communication, and then ESX to ESX communication. Just a fantastic little tool from VM, which is one of our sponsors. But put that aside. That's not why I'm plugging this. This is a tool that I actually use on a day-to-day basis, and you're gonna find it extremely handy when you're trying to transfer files from and to an ESX server, especially if you have a lot of those files on a Windows-based operating system or machine. Now, once we've imported etc group and etc password, what we're going to do is we're going to map the Windows administrator to ESX root. What this means is you'll be able to pass the credentials of Windows administrator to ESX root. We're going to synchronize them, so to speak. And after that, then we're going to go ahead and add an NFS storage to ESX 3.5. Now, from this entire exercise, we're going to go through slides about how to install and configure this. But the main thing that we're going to be focusing on is how to add an NFS storage to ESX 3.5. Alright, so once you've installed the Windows services for Unix, and you create any folder wherever you want it located on your Windows operating system, once you right click that folder and go to sharing, you're going to notice that you now have a new tab called NFS sharing. Now within NFS sharing, you can configure the share name. Now be careful to share name here, because share name is case sensitive. Because I'm a Windows guy, I had to learn this the hard way. If you put NFS, for example, the way we have it on this screen, capital NFS on capital W Windows. If you try to access this with all lowercase, you won't be able to access it. So pay attention, mind your capitalization here. Now once you put the share name, you can go ahead and go in permissions and then set the right permissions that you want. Once you install the Windows services for Unix, you get an MMC console, kind of similar to what you're seeing here, which is, it's really cool actually. I'm going to let you guys play around with it. But if you go to username mapping on the left and you click on that, then towards the middle of the screen where you see user network information service, beneath that you have user password and group files. So this is where you would, once you copy over the password and group files from an existing ESX 3.5 server. Let's say you put them on a directory on your C drive called Linux files, and then you put both files in there. Then you'll be able to browse from here and specify those files. Those are the files that are going to tell this Windows server which groups and which users to map, which groups and which users exist on ESX 3.5, and which groups, it gives it the opportunity to map these groups to Windows users and Windows groups. And let me show you what the mapping looks like. Now on this screen you're going to see that we've highlighted administrator and we're mapping that to root. So on the right here you're going to see all the users and groups that we've loaded from that user and groups file that we brought in from ESX 3.5, and then on the left here you're going to notice that we're looking at all the local users and groups that are available on a machine that we call manager. You'll notice that up there where we have the whack and then manager. Alright, now this time you're ready, you have everything configured, and you're ready to present NFS storage to your ESX servers. Now before we go ahead and log into the VI client and start doing some of that stuff, what I want to do is I want to skip over to one more slide, show you some command lines on how you can create NFS data stores using the command line, and then we can go into the VI client. That way we'll be done with the presentation part. Alright, so on this slide there are steps that you can follow if you wanted to create NFS access through command line. Now I'm not going to go ahead and read everything to you. I'm sure you guys can read. So I'm just going to keep the slide up for a few seconds here. Now you can feel free to pause the video anytime you wanted to do these steps or follow these commands from a command line. They're available to you. Alright, let's go ahead and log into the VI client and let's attach an NFS device or an NFS storage to ESX 3.5. Alright, so we're inside the VI client here. Now at the beginning of the module I told you I would show you where we could go to increase the maximum size of allowed, or to increase the maximum allowed NFS data stores within ESX. Now what we want to do is, again, I told you guys you would be living inside the configuration tab, so we're going to click on configuration. We're going to click on advanced settings. This opens up a new window, and then on the left we're going to click on NFS, and we're going to scroll down a little bit to where we see, so we're going to look at NFS max volumes. Now as you can see, the max that you can set it to is 32, and by default it's set to 8. So if you wanted more than that, you could just modify this, click OK, and you're golden. So let's get out of here and go ahead and attach an NFS storage. So like I told you before, NFS follows the same rules as iSCSI, so let's just go through those one more time. So we need a virtual switch that has the VM kernel and also has the correct VM service console attached to it. So this virtual switch here, we have IP storage, which is a port group of type VM kernel that we've configured for our iSCSI, and we also have the service console. So let's go ahead and attach NAS now. So what we're going to do is we're going to click on storage, we're going to click on add storage, and this is where you select NAS or NFS. We're going to click on network file system, we're going to click next, and we are going to put in the IP address of the NAS device and the directory. Now keep in mind here, what did I say? Mind your capitalization. So we have NFS on Windows here. I'm going to mount this as read-only so that we can't make any changes to this. This would be a great idea if you had ISOs, if you wanted to share stuff, but you didn't want anybody to make any modifications. Just mount it NFS read-only. Now the data store name that we're going to give this, let's give this NFS1. Click on next. Yes, we're sure. There it is. NFS1, it's mounted as read-only. There you go. Now if you expand this a little bit, you're going to notice that this is the NFS that we're mounting, the share name, if you want to call it. This is how much free space is available on this thing. That's a lot of free space for a Windows box. And then you can see the type is NFS, so it's going to clearly identify the NFS device from the type that you see here. And that's it for NAS, NFS. That's all there is to it. It's very simple, very straightforward. It's awesome stuff. I invite you to play around with NAS and NFS. Experiment with it, whether it's for ESX or for anything else. It's truly a great technology that you can take advantage of. And we got plenty of servers, plenty of PCs that have a lot of disk space that we don't know how to make accessible to the network in an easy way, easy format, this is perfect for that kind of stuff. Alright, so this part of the module, of the storage module, we're going to dedicate to VMFS. This is really cool stuff here. Now, as I've been telling you all along, VMFS is a proprietary file system built for optimal execution of virtual machines that are available on local storage, fiber channel storage, or on iSCSI storage. And as you should know by now, VMFS is used for the storage of virtual machines, of their ISO files, and their templates. And to continue on with some basic guidelines and some stuff that you know, every virtual machine that's created on a VMFS data store will be stored in its unique folder, and this folder will be named after the virtual machine name. So whatever the virtual machine name, that's what the folder name is going to be. Now, VMFS data stores can be managed either via the VI client connecting to a virtual center server, or via the VI client connecting directly to an ESX host, or obviously via an SSH session. Now, the way that you would identify or reference VMFS data stores is one of three ways. You can either reference it via its friendly data store name. So for example, in the figure down here, you're going to notice that the data store name is shared VMs, or via the four-part device name, or via the unique ID assigned by the ESX host. Now we're going to log into PuTTY in a second, and I'm going to show you the unique ID that's assigned by the ESX host to every data store. But before we do that, let's go through this lecture real quick. Now, earlier I said the four-part device name. Now you can see it here, and the highlighted friendly name is LUN3, for example. The device name is going to be VMHBA1031. That's going to be the four-part device name. Now, the cool thing about the ESX assigned name is that when we browse, when you go through PuTTY, for example, or an SSH client, and you're browsing through the directories, you're going to browse through the volumes directory, and it's going to look like this. Every data store is going to have a friendly name attached to it. So at the far right here, you're going to see, for example, LUN10, LUN21, LUN23. Now LUN21 being the friendly name, and then before that in orange, that set of numbers that you see, it's alphanumeric, by the way, that is the unique ESX assigned ID to every data store. And I'll show you how you can see this unique ID either via PuTTY or from within the VI client. You can find it both ways, browsing it through PuTTY or looking at it through the VI client. Alright, so let's launch the VI client and let's go ahead and create a data store, and then we can go through the multiple configurations that we've been talking about here. Earlier on during this module, I told you once we logged in and we were talking about fiber channel and VMFS, I would show you where the storage adapters would be. And I'm sure you figured it out by now, but just in case you haven't, this is where storage adapters would be. And then you're going to notice that I have a fiber channel HBA card in this server. Now, what we're going to do is we are going to create a VMFS that is available on one of the LUNs that we've presented to this ESX host. So let's go ahead and click on storage here, and what we're going to do is we're going to click on add storage, and we'll be adding a disk LUN. The second option would be used to connect to NAS or NFS, and we will do that. And you're going to notice that I don't have any LUNs. So, what do I do? I can't see any LUNs. So what we're going to do is we're going to click on cancel here. We're going to go back to our storage adapters, and we're going to do a rescan on the storage adapter in order to see if we can see the LUNs on it. And we're going to keep both options checked. Click on OK here. And voila, you're going to notice that we are seeing a lot of LUNs that are being presented to this ESX server right now. So let's go ahead and go back into storage. And then let's click on add storage. Disk LUN again. And there you go. At this point, we're going to have to choose which LUN we want to format as VMFS. Let's go ahead and take this one. 50 gig should be enough for us. We're going to click on next, and let's name this thing prod1. We're going to click on next here. We're going to keep these at the defaults. Now this is where you can select the maximum file size and block size among the options. Now the options that you have are as follows. You can do 256 gig block size, you can do 512, 1024, 2048. Now, as best practice, you want to leave the maximize capacity option enabled. Contention occurs at the LUN level, not at the partition level. So you want to leave this at the default. We're going to go ahead and click next here. summary, and we're going to click on finish. And voila, there you go. Now if you go to the summary page here, you're going to notice that you have a new data store called prod1, which we've just created. Let's go back into configuration for a second. Let's talk about the friendly name that we were talking about. So the friendly name for this LUN that we've just created, for this VMFS data store that we've just created, is what? It's prod1, exactly. Now what would be the 4-part device name or number? That would be VMHBA0006. However, what is the ID that the ESX host is giving this VMFS data store? You can see that over here after volumes. Now let's go into the properties here for a second. Oh, whoops, wrong one. We went into the properties of the local storage. Let's select the LUN. Now again, you'll notice the unique ID that the ESX host has specified. I'm going to minimize this in a second. We're going to bring up PuTTY, but let me show you inside properties here. Again, you'll see the friendly name of the data store. You can always change that. We're going to come back in here when we start talking about extents, but these are the properties that you can check for the actual VMFS data store that you've just created. The VMFS file system version, maximum file size, the block size, etc. Alright, so let's go back. Let's get out of here. This is the ID, and let's go and launch PuTTY and see if I can browse to that and show you what I mean by that. So we're going to... Alright, so we've logged in. Let's go ahead and go up to the root here, and then let's go do a cd/vmfs, and let's go into cd/volumes, which is the repository for where all the volumes are located. Let's do a list here. Alright, so I'm not supposed to be putting a slash, so let's just do cd volumes, and then let's do an ls here. Alright, so you're going to notice here that the friendly name, again, of the data store is prod1, and then the ESX assigned ID would be as such. Alright, now let's talk a little bit about extending a VMFS volume. Now, I told you that the maximum size of a VMFS volume is 2 terabytes. Now, what if you wanted to go beyond 2 terabytes? Is there a way? Now, of course, there's a way. There's always a way to do things in computers. So what you do is you end up creating a 2 terabyte VMFS data store, and then you extend it, for example, with another 2 terabytes to end up with a total of 4 terabytes. Yes, you can do that. So VMFS data stores can be extended to include 32 units of storage for a maximum of 64 terabytes. But again, and by definition, I'm reading a definition for you here, a maximum file size remains capped by the configuration of the first LUN, never to exceed 2 terabytes. This is important, keep this in mind. Now, when you're adding extents, you do not need to take the data store offline. Let's go ahead and do that since we have the VI client up here. Let's bring it up and let's extend prod1. So let's go into the properties of prod1 and let's add an extent. Let's choose an extent. Let's take another 50 gig. Let's click on next. Next, we're going to keep everything at the default and we're going to click finish. And look at that. Let's close out of here. And if you notice that the capacity of prod1, it just doubled. It's now about 100 gig or 97.50 gig in space. Now, a word of caution here. When you go to extend the volume, if you have LUNs or storage that's formatted as NTFS, it's going to show up as a candidate for extent. Now you got to be careful not to select that. If you select that and there's valid data on it, you might end up blowing away valuable data. You don't want to do that. You know, restoring data is the last thing that you want to do. Now here's the $1,000,000 question, and I've learned this with tears, so listen up. How do you remove an extent? You guys can browse around the VI client all day. You can do whatever you want. The short answer is there is no easy way of removing the extent. If you remove the extent, you're going to destroy the data store. You're going to have to delete it, and that's the only way to restore or to separate or split back the LUNs. There's no clean way of doing it per se. So you got to be careful when you're extending it that, you know, if you want to remove it, it's going to be a hassle. So plan accordingly. So let's do that. Let's go ahead and break this extent. Let's just remove it completely. Let's do a remove here. And yes, I'm sure. And voila. There you go. Come up here, it's gone. So let's go ahead and create it real quick because we're going to be using it for some other stuff. So again, let's go through add storage. We're going to select this CLUN, and there it is. It's available again. We're going to click next, next. Let's call it again prod1. Next, we're going to keep the defaults. Finish. Alright, let's go back to our presentation. Let's talk a little bit about multipathing, and then we're going to come back to the VI client, and I'm going to talk to you, show you how we can do multipathing here. So what's multipathing? Alright, so in ESX and in virtualized environment in general, one of the most important components, if not the most important component, and I told you this before, is storage. Because everything resides on the storage. And the way we access this storage is either going to be via some fiber channel HBAs, iSCSI HBAs, or software initiators, etc., etc. Now, getting to the storage is a critical part. You want to make sure that you always have a backup route, just in case the initial route fails. You'll have a secondary or a plan B, a backup route to get to your storage without affecting performance. Because if we're going to be using virtualization for enterprise class production environments, then we got to make sure that these systems stay up. And we got to build redundancy in them that stay up, because we're putting 20, 30 VMs on a host. We don't want to lose access to these VMs or make sure these VMs stay up just because an HBA went bad or just because something happened. So we want to create a lot of redundancy within the environment to help make this a stable environment and make it run as optimal as possible. Now, that being said, multipathing is the ability to utilize multiple paths to access a unit of storage. So with ESX 3.5, you have native multipathing. You don't need the installation of any third-party software to make this technology possible or these features possible for you. ESX 3.5 supports 3 different types of multipathing, most recently used, fixed, and round robin. Now let's take a look at each and every one of those 3 features. Now, with most recently used, this approach is typically a reactive approach to a problem that happens. You're reacting to a problem, you're not being proactive here. And the reason I say that is because the most recently used multipathing policy provides failover across paths but does not provide failback. So if you have, for example, in the figure that we have shown here, we have VM HBA1 that's experiencing a failure. ESX will fail over to VM HBA2. However, if VM HBA1 becomes available again, the path on VM HBA2 will remain the active path. So it does not provide for failback here. Now, with the fixed multipathing policy, you as the administrator is being proactive by defining the order of path precedence. So again, in the figure that we're shown here, if VM HBA2 experiences a failure, ESX will fail over to VM HBA1. And if VM HBA2 becomes available again, it will return to using VM HBA2 as the active path. So you see how there's failover and failback here. So once the failed adapter becomes active again, it restores it as the active path. Now, round robin is really cool. It's a new feature of ESX 3.5 that works off of performance basically. So if the active path becomes saturated, then round robin, the policy round robin kicks in and fails over to a different path to alleviate some of the performance strains that the active path might be experiencing. So MRU and fixed paths only respond to failures, whereas round robin is going to respond to performance degradation as well. So by default, round robin operates under the following guidelines. So if a new path is switched when more than 50 IO requests are issued against the active path, a new path is switched over to again when more than 2048 IO blocks are issued against the active path, the new path selected by round robin uses MRU to select the target and selects any available HBA. Now I'm going to show you a couple of slides that I've put together here for you that are just for your information, for those of you that want to know more. Now, usually multipathing is configured through the VI client, but for those of you that want to use command line to customize multipathing, you're more than welcome to do so, and I've provided this slide, and you can pause the video if you want to review this. And I've also provided the following slide for more information on how to use multipathing from a command line. Now, before we get into the VI client and start doing some multipathing tweaks, let's take a look at the difference between fiber channel multipathing and iSCSI multipathing. So what's the best way of doing multipathing for fiber channel inside of an ESX host? Now, today you're going to find HBA cards that have dual ports, and those are awesome. They're great, especially if you're on a server that has limited PCI slots. You definitely want to go that route. However, if you're building an optimal environment, if you want the best way of doing it, you probably want two HBAs that are single port HBAs each. And the reason for that is you want to eliminate as many single point of failures as you can. Now, I know, and I'm from the school that says you cannot eliminate single point of failure altogether. You know, at the end of the day, Earth is a single point of failure. So, but what we try to do as administrators, engineers, and architects is we try to limit the single point of failures wherever we can and whenever we can to a certain extent. Now, by providing two HBA cards that have single ports on each of them, you've eliminated the single point of failure of having an HBA card with dual ports and doing multipathing with that. Because if you lose the actual card, then all your multipathing efforts have gone to waste. They're useless. Now, similarly to having two HBA cards with single ports in them, you want to connect those single port HBA cards to different fiber channel switches, so that the route is taking a completely different route, and again you're eliminating the single point of failure at the switch level where the connection happens between the HBA card and the fabric or the fiber channel switch. Now, the third component, where the HBA card connects to the fabric and the fabric then connects to the storage processor, which gives us access to the LUNs and the actual devices, again you want to have at least two storage processors there for multipathing and for failover and all that good stuff. So again, you want to try to do things in twos whenever possible, whenever cost is not an issue, because this stuff also costs a lot of money. But then again, you're going to have to weigh the cost versus how important it is for you to keep your systems up and running the best way you can. Now, if we move on to iSCSI storage, if you're using the software initiator, then what you want to do is take advantage of NIC teams as much as you can. When you're constructing your virtual switch that has the IP storage or connecting the iSCSI storage from it, you want to try to use two NICs for redundancy that way. If you're using the hardware iSCSI initiator, then the same rules apply as the fiber channel HBA cards. Just use two single port HBA initiators for iSCSI. Same rules as with fiber channel. You want to try to connect to two different Ethernet switches. Gigabit switches are recommended, of course. And you want to deploy an iSCSI storage device with multiple Ethernet ports. So same with the storage processors, where they're connecting us to the actual hardware. The destination iSCSI storage needs to have multiple path, multiple ports, so that we can do multipathing and have more than one entry and eliminate as much single point of failures as we can. Alright, so let's go back into the VI client. Let's do some multipathing. Enough of this lecture stuff. Let's do some good work. Alright, so we've logged into the VI client here. Let's go to configuration, and we're going to click on storage even though we're in there already, and we're going to select the first data store here. We're going to click on properties, and we're going to click on manage paths, and there you go. If we click on change here, you are going to get the option of changing fixed to MRU, to most recently used, or MRU, or round robin. Now they're saying it's still experimental, which it's kind of beta, but I've tried it. It works nicely. If you've sized your SAN and your disks properly, then you probably won't take advantage of round robin too much, because then performance shouldn't be affected. But in the event where you want, or you think you're experiencing performance as far as your I/O is concerned, switching it to round robin will help you a great deal. It actually works fine. So fixed is chosen by default, and unless you have a need to and you want to architect your strategy or storage strategy differently, I'd recommend you keep it. It provides for failover and failback at the same time, whereas MRU will only provide for failover. Round robin, even though it's still experimental, it's based off of performance. So if you're experiencing performance on one of your HBAs, or one of the LUNs, it's going to switch over to a different path to try to alleviate some of the performance strains that might be put on this particular path or on this particular LUN. So let's cancel out of here real quick and go back to this screen. And you're going to notice here that this is the active path. The first one here is the active path. So let's click on OK here. Actually, let's go back in here real quick. I want to show you guys one more thing. If you select one of those two and you click on change here, you're able to either set this thing to enabled, where it's going to participate in load balancing, or if you set it to disabled, that means you don't want to use this path yet. Maybe you're using this as a standby, it hasn't been configured. For whatever reason, if you set this to disabled, it won't route traffic through this path. So this is kind of a cool thing to know, just in case you need to do something like this, or you need to disable a path or a route temporarily and then re-enable it later on. So we're going to click OK to exit out of here. Click close to exit out of here, and let's minimize this thing. That's all, folks. It's been a long module. Storage is a pretty long module, but as you can see, storage is important. It's imperative to the functionality of your virtual infrastructure. I hope this module has been informative for you, and I'd like to thank you for viewing, and I'd like to invite you to continue on. Let's push forward. Let's learn a little more about ESX 3.5.